Hello class, this is Chapter 6, Algebra, Equations, and Inequalities. We're looking at the last section in Chapter 6, Chapter 6.5, Quadratic Equations. Our objectives today are to multiply binomials using the FOIL method, factor trinomials, solve quadratic equations by factoring, solve quadratic equations using the quadratic formula, and solve problems modeled by quadratic equations. So let's first look at multiplying two binomials using the FOIL method. A binomial is an algebraic expression containing two terms in which each exponent that appears on the variable is a whole number. Examples: x plus 3, x plus 4, 3x plus 4, 5x minus 3. Those are all examples of binomials. Now the FOIL method itself stands for first, outside, inside, last. We multiply the first terms in the sequence, the last terms in the sequence, the inside terms in the sequence, the outside terms in the sequence. Really doesn't matter the order, but typically we go first, outside, inside, last. Stands for FOIL. So if we have two terms, ax plus b times cx plus d, we multiply the first, ax times cx. That gives us the f in FOIL, the product of the first terms. Then we do ax times d, that's the outside, the o in our FOIL method, the product of the outside terms. B times cx, that's the inside, the I in the FOIL method, the product of the inside terms. And then b times d, the last, the product of the last terms in the FOIL method. So let's put pen to paper and do an example. Example 1 using the FOIL method. Multiply x plus 3 times x plus 4. Solution. Let's multiply the first terms. First terms are x times x. That's x times x, which gives us the x squared. Let's multiply the outside terms. X times 4 gives you the 4x. Let's multiply the inside terms. 3 times x gives you 3x. And then we will multiply the last terms. 3 times 4 gives you 12. Then we add all those together. So x squared plus 4x plus 3x plus 12. We simplify by combining like terms. In this case, the only like terms we have are 4x and 3x. We add those together, we get 7x. And we're done. X squared plus 7x plus 12 is our final answer after FOILing. Now let's factor trinomials whose leading coefficient is 1. Now let's define a trinomial. A trinomial is a simplified algebraic expression that contains three terms in which all variables have whole number exponents. We can use the FOIL method to multiply binomials to obtain a trinomial. So in its factored form, x plus 3 times x plus FOIL. X plus 4. We FOIL it out, we get x squared plus 4x plus 3x plus 12, which simplifies to its trinomial form, x squared plus 7x plus 12. If we look at factoring, an algebraic expression containing the sum or difference of terms means finding an equivalent expression that is a product. So when we do the FOIL method, we take it from factored form to trinomial form. When we factor, we go from trinomial form back to factored form. So learning to go both ways here. So there are many different strategies for factoring a trinomial. When it's simple and has just a 1 in front of the x squared, so it looks like x squared plus bx plus c, we can go by this simple strategy here. First, we're going to enter an x as the first term of each factor. So we're splitting this up here into an x plus or minus something times an x plus or minus something. We'll see when we get to the actual numbers what that is. But essentially, breaking it up into two sets of parentheses where x is your first number in both. So try to do a better parentheses there. My bad. That one's kind of ugly. All right. Number 2, list pairs of factors for the constant c. So we'll list the pairs of factors for constant c, and then we'll try the various combination of these factors of the second term In each set of the parentheses, select the combinations in which the sum of the outside and inside product is equal to bx. Okay, this will make a little more sense when we put pencil to paper. Step 4, we're going to check your work. By multiplying the factors using the FOIL method, you should obtain the original trinomial. Always good to check your work when you're doing factoring, because if your FOIL of your factor there doesn't work out, that means you did the factoring part wrong. If none of the possible combinations yield an outside product and an inside product whose sum is equal to the bx, the trinomial cannot be factored using integers and is called prime. That does happen sometimes. Let's look at an example. So factoring a trinomial in x squared plus bx plus c, we have the example x squared plus 6x plus 8. Now, step 1, we want to enter the x as the first term in each factor. They've done it here. I'm going to write it bigger over here to the side because I like some space to work with. So I'm just going to make the parentheses a little bit wider there. Now, second step is we're going to look at and list all the factors of the constant 8. Okay, so factors of constant 8 are 8 and 1, 4 and 2, negative 8, negative 1, negative 4, and negative 2. Okay, typically when I do this, I just do 1 and 8, and then 2 and 4. And then you kind of got to recognize here that if you do make them both negative, it can turn into a positive 8 as well. Now, we need to try the various combinations of these factors. The correct factorization is the one in which the sum of the outside and inside products is equal to 6. Essentially, we look at the factors, right? So, 1 and 8. Can I make a 1 and an 8 add or subtract together to be 6? I can't. Neither can I with negative 8 and negative 1. But if I look over here at 4 and 2, 4 and 2 add together to give me 6. So that's the combination I'm hoping for. If I add 4 and 2 together, I get 6. So that's what I'm going to put in my factor there. So you can list out all the possible factors here if you wanted to. So essentially what it does is it plugs in every combination into your factorization in this chart. And it says, okay, if I work it backwards, this is what I get. If I work it backwards, this is what I get. If I work it on through, this is what I get. And it's just looking at the middle terms. It's looking at 8 times x and then x times 1. So you get your 1x plus your 8x. That gives you a 9x. This is the only one, like I said, the 4 and the 2, that give us that middle 6x that we actually need. To me, this is a little overcomplicated here. All you really have to look at when you look at those factorizations back here is which one is going to add together or subtract together to give you this term. So you don't have to overcomplicate it and write you a whole possible chart out here if you can just do a little math in your head. Thus, our factorization of x squared plus 6x plus 8 equals x plus 4 times x plus 2. Now we're going to check it. If you do check it, all you're going to do, if you want to do a check step, all you have to do is FOIL it out. If you FOIL it out, you get x squared. Outside would be 2x, inside would be 4x, last would be 8. This simplifies down to x squared plus 6x plus 8, which was our original. So we've checked it. Simple enough. Now, where it gets a little more difficult here is the factorization when you have something other than 1 out in front of your x. Okay, so step 1, find the first two terms whose product is 3x squared. Okay, now with 3x squared, you only really have one thing that it could be. Okay, because this is a prime number out in front of your x, so its only factors are 3 and 1. So we're going to go with 3x and x because the only factors of 3 are 1 and 3. Okay, not going to mess with the negatives here. You never really want your first term to be negative when you factor if you can help it. Alright, so we got a 3x here, we got an x here. So we've determined what needs to be first. Now we look and list all the factors of 28, because the middle term, negative 20x, is negative. Both factors must be negative. Therefore, the negative factorizations are negative 1 and 28, negative 2 and negative 14, and negative 4 and negative 7. So essentially all we did was factor and find the factors of 28. 1 and 28, 2 and 14, 3 does not go into 28, but 4 does. 4 and 7. Okay. So we listed them all. We do know they have to be negative because this middle number has to add up to be a negative here. So whatever we combine essentially has to wind up being negative. Now we need to try various combinations of these factors. Okay, so your possible factorizations are all of these ones that are listed. And this is where it gets a little intense. Okay, because what you could do with the guess and check method is you basically write your 3x and your x all the way out front, all the way through, and you try every combination of the factorization of 28. So you try -1, -28, -28, -1, and you do have to switch them because each of the x's has a different number out front, and you basically guess and check it until you wind up with a middle sum here that is the middle sum that you're looking for. So that your factorization here is 3x minus 14 times x minus 2. Okay, you can verify it using the FOIL method as well. Now, here's what I'm going to do. Okay, now this isn't taught in your textbook, but this is the way that I typically teach factorizations here. Okay, so we have our formula here. This is your A, this is your B, this is your C. If you want to look up what I'm about to do, it's called the X method. Okay, there's plenty of great videos on YouTube of how to do the X method. Okay, so what I'm going to do here is I'm going to draw an X. Okay, I'm going to put AC up top. I'm going to put B down at the bottom. Okay, now here my A is a 3. Here my C is a 28. Okay, my B is a -20. 3 times -28 is, let's check this on the calculator because I don't want to tell you wrong. And I don't feel like writing it down right now because I only have limited space here to work this. So 3 times 28 is 84. Okay. Now, I need factors of 84 that add up to give me -20. Okay. So if I look at factors of 84, okay, of course there's 1 in 84. That's always the easiest one, right? And then 2, let's see. We're going to look at 2 and, what is that, 42? Okay, those aren't going to give me -20. Let's keep going. 3 and 28. Okay, that's not going to get me to -20. I don't care how you combine it. Let's look at 4. 4 goes into 84. 4 goes into 84, looks like 21 times. I can't combine 4 and 21 to be 20 either. 5 doesn't go into 84. Let's see if 6 goes into 84 though. So 6 goes into 84. Let's see, 1 and 2 left over. I think 14 times. You could double check me on that. 6 times 14 indeed is 84. What's special about 6 and 14? 6 and 14 can add together to be 20, which means they can subtract together to be -20. So I'm going to write them here in this opening in my X. Now the key here is that I need to put them over top of my A value. And you'll see what's about to happen when I do that. Okay. Now if I do -6 divided by A, here my A is 3. So I need to put -6 over 3. And over here I need to put -14 over 3. Now watch what's about to happen. I simplify if possible. I can't simplify -14 over 3. But I can simplify -6 over 3. That simplifies to -2 over 1. And I do want to keep that 1 down there. Here's why. Because I now have everything I need in these two numbers to write my factored form of my equation. Watch this. I'm going to take the bottom number here, which is 1. I'm going to put that on my X, and I'm going to use the top number as the constant. So I'm looking at 1x minus 2. In my other factor, I'm going to have a 3, put that in front of the x. So I'm putting the bottom number in front of my x, and then the top number is my constant. Now, I'm going to rearrange it so it looks the same as their answer. This is the same thing as 3x minus 14 times x minus 2, which is the same thing they got here as their answer, without having to do a plug and check 1, 2, 3, 4, 5, 6 times. Now, if you're going to use the X method, I highly, highly, highly recommend that you go onto YouTube and you search the X method. You practice it with your homework. Make sure you got the method down. Because the X method is not something that you're going to be able to do one time and then have it and remember it forever. The X method requires practice. Okay? But to me, the X method is simpler than factoring here. What I want to see is that you can factor. The method you use to factor is not important to me, as long as it's legitimate and it works and it gets you to the correct final answer. So if you use the guess and check method to factor, that's fine. If you use the X method to factor, that's fine. If you use factoring by grouping to factor, that's fine. I don't care which method you use to factor as long as you're able to factor. There's a couple other methods out there too. You're welcome to YouTube those. As long as you have a solid method that gets you to the correct final answer, perfectly okay with you using that method to factor. Okay. So, solving a quadratic equation by factoring. A quadratic equation in X is an equation that can be written of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers with a not equal to 0. The zero product principle states that if the product of two factors is 0, then one or both of the factors must have a value of 0. Essentially, if a times b equals 0, then either a has to equal 0, then either a has to equal 0 or b has to equal 0, or technically they could both equal 0. Basically just says if you got two things that are multiplying and they wind up multiplying to be 0, then one of them's got to be 0 or either both of them's got to be 0. But you can't have any number that multiplies by something and turns it to 0 without one of those numbers being 0 themselves. Alright, so solving a quadratic equation by factoring. If necessary, rewrite the equation in the form ax squared plus bx plus c equals 0, moving all terms to one side, therefore obtaining a 0 on the other. It's not always written where you have a 0 on one side. Sometimes you have to move stuff over so you have a 0 on one side. Do that first. That's step 1. Step 2 is to factor, whatever method works best for you. Step 3 says apply the zero product principle, setting each factor equal to 0. Step 4 says solve the equations in step 3. And step 5 says check the solutions in the original equation. Now, let's move through this and do it. We'll start out with an easy one here. I've got a 1 in front of the x, which makes factoring much, much simpler. So we're starting with solve x squared minus 2x equals 35. The first thing we're going to do is get everything on one side and 0 on the other. In order to do that here, I need to subtract 35 from both sides. Okay, that's going to cancel the 35 out here. It's going to give me my 0. It's going to put a negative 35 on the left-hand side. And I'll be set up to move on through. Okay, so we've done step 1. Step 2, we want to factor. Okay, now because I have a 1 out in front of my x squared, I can just start my factoring out with an x and an x. Simple, easy. Then I look at the last term here, the 35, and I look at the factors of 35, or in this case negative 35, that could add or subtract together to be negative 2. I'm looking at 1 and 35. That's not going to do it. 2 doesn't go into 35, 3 doesn't go into 35, 4 doesn't go into 35, but 5 does. I look at 5 and 7. Those are two factors of 35 that I could probably get a 2 out of, right? I could get a 2 out of that by making the 7 negative and the 5 positive. See what I did there? So I found a factor of 35 that had a difference of 2, or had a combination that could give me 2, or in this case, negative 2. And I used that combination and plugged that combination in. Okay, now steps 3 and 4, we need to set each factor equal to 0 and solve each resulting equation. So now that I have it in terms of multiplication here, x minus 7 times x plus 5 equals 0, I set each one of those multiplications, the x minus 7 and the x plus 5 here, equal to 0. So here I set x minus 7 equal to 0. To solve for x, I add 7 to both sides. and I get one of my solutions is x equals 7. Here I set x plus 5 equal to 0. I solve for x by subtracting 5, and I see that my other solution is x minus 5. So I have two solutions here. One of them is x equals 7. The other one is x equals negative 5. Step 5 says check the solutions in the original equation. So we're going to check 7 first. So I plug 7 in everywhere I see an x. So I wind up with 7 squared minus 2 times 7 equals 35. That gives me 49 minus 14, because 7 squared is 49, and negative 2 times 7 is negative 14. 49 minus 14 is 35. This is a true statement. I check negative 5 as well. So negative 5 squared is 25. Negative 2 times negative 5 is positive 10. 25 plus 10 is 35. So both of my solutions work, and both of my solutions are therefore true. Now, if we cannot factor something, because you can't always factor, sometimes we have to use what is called the quadratic equation. So solving quadratic equations using the quadratic formula. The solutions of the quadratic equation in the form ax squared plus bx plus c equals 0 and with a not equal to 0 are given by the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, it says here in the little sidebar box that x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. That's literally what I just wrote out and said. Alright, so we have our quadratic equation. That's something that if you plan to proceed further with mathematics, that you should definitely memorize, because we use that a lot. Alright, so I'm given one of my quadratic equations here. So I've got 2x squared plus 9x minus 5. Now, you could go through here. Alright, I'm just going to do a little aside real quick. I'm going to use the x method, see if maybe I can factor this, right? Because I've got a 2 here on my a, I've got a negative 5 here on my c, which means I have a negative 10 here. My b is a 9. I need two factors of negative 10 that adds to 9. Oh Lord, maybe a negative 1 and maybe 10. Okay, because 10 minus 1 is 9 and negative 1 times 10 is negative 10. I put that over my a here. Boom. So this one doesn't reduce, but this one does. This reduces to 5 over 1. So technically, if I factored it, it would look like 2x minus 1 times x, imaginary 1 out in front of that x, plus 5 equals 0. Now, I was able to factor this one. But let's say you weren't able to factor it, or you just couldn't figure out the factorization, but you still wanted to solve the problem and get your full credit. You could use the quadratic equation. I'm going to go ahead and finish solving with the factoring first. We set 2x minus 1 equal to 0. We set x plus 5 equal to 0. I add 1. I get 2x equals 1. I divide by 2. I see that x equals 1/2. And I subtract 5 over here on the other equation. And I see that x is supposed to be negative 5. So I was able to actually factor this one. But sometimes it's hard to see how to factor it, or you forget how to do the x method, or you get stuck on something. The quadratic equation always works. So let's see how it would have turned out with the quadratic equation. Now my b is my 9, so I'm going to plug in negative b, so negative 9, plus or minus the square root of b squared, so I'm looking at 9 squared, minus 4 times a, which in this case was the 2, times c, which is the negative 5, all over 2 times a, which is the 2. Now we work on the simplification. So negative 9 plus or minus 9 squared is 81. Negative 4 times 2 is negative 8 times negative 5 is positive 40. And 2 times 2 is 4. So all over 4. Now 81 plus 40 is 121. So I'm looking at negative 9 plus or minus the square root of 121 over 4. The square root of 121 is 11. So I'm looking at negative 9 plus or minus 11 over 4. Negative 9 plus 11. I'm going to break it into my two things because it's plus or minus here. I don't want to leave my solution like this because we can simplify this. So I'm going to break it into the plus in this piece and the minus in this piece, because you're going to have two solutions. We've seen that in our factoring already. So negative 9 plus 11 over 4. Negative 9 plus 11 is 2 over 4, which reduces to 1/2. So this is one of our solutions. Or our other solution, negative 9 minus 11, gives us negative 20 divided by 4 is negative 5. So you can't factor them all. I just happen to be able to factor this one using the X method, but there are ones that are not factorable. If you struggle with factoring, the quadratic equation, if you can memorize the formula, works on all of them. Get it equal to 0, it works on all of them. You can plug it in the quadratic equation, solve it on through, get your two answers. You don't even have to worry about factoring to solve. Or, like I said, sometimes you're just struggling with factoring, and it is one that'll factor, but you just can't figure out how to do it. You can always revert back to the quadratic equation to help. Okay. Now, example 11, it says, solve 2x squared equals 4x plus 1. Now, the first thing we got to do is get everything all on one side. So we need to move all the terms to the left, actually, here. We're going to move all the terms to the left. I don't know why it says to the right. If we moved them all to the right, you could move them all to the right. Here, I'm going to actually move them all left. Okay, so I'm going to subtract 4x over to the left-hand side. I'm also going to subtract 1 over to the left-hand side. And that's how I get the 2x squared minus 4x minus 1 equals 0. Okay, so in this case, my a is 2, my b is negative 4, and my c is negative 1. Now you can go ahead and try to factor this one, but good luck. I don't think you can do it. I could be wrong, but I don't think you can. I don't believe you can. All right, so let's look at it here. I'm going to plug it in the quadratic formula. So I'm going to do negative b, so negative 4. So negative 4 plus or minus the square root of b squared. I do want to put this in parentheses here because it's a negative 4 squared, and that negative is actually squared here. Minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2. So let's do some reduction. Negative 4 turns it into a positive 4, plus or minus the square root. Negative 4 squared turns it into 16, and it's positive. That's the reason I told you to make sure your negatives in your parentheses. Minus, okay, if I do 4 times 2 times negative 1, that does give me negative 8. Okay, that minus turns essentially into a plus here. Okay, so I'm looking at 16 plus 8. That's where I get the 24 from. So I get 4 plus or minus the square root of 24 over 4. That 4 on the bottom is 2 times 2. X equals 4 plus or minus. Okay, so what I've done here in this step is reduce this square root. Okay, so I don't know the square root of 24, but I do know that what I could look at is the square root of 4 times 6, because 4 times 6 is 24. And I do know what the square root of 4 is. The square root of 4 is 2. So that technically reduces to your 2 square root 6, because the square root of 4 is just 2. That's where they get this piece right here. So I get 4 plus or minus 2 square root 6 over 4. And if I want to reduce, because these all have 2's in common, I can divide essentially all these pieces by 2. So that divided by 2, this piece divided by 2, this piece also divided by 2, and cancel this 2 out, which gives me 2 plus or minus the square root of 6 all over 2, right? Which means one solution is 2 plus the square root of 6 over 2. The other solution is 2 minus the square root of 6 over 2. And those are my two solutions. Okay. Note that if the expression under the square root simplifies to a negative number, then the quadratic equation has no real solutions, because we can't take the square root of a negative. Okay. Let's look at example 12a, blood pressure and age. A person's normal systolic blood pressure measured in millimeters of mercury depends on his or her age. The formula P equals 0.006 a squared minus 0.02 a plus 120 models a male's normal systolic blood pressure P at age A. Find the age to the nearest year of a male whose systolic blood pressure is 125 millimeters of mercury. That's what Hg stands for, mercury. Okay, so what we're looking at here, we can look at the chart on the right hand side too and see that male and female are different in this case. So the male is increasing here, and then at some age, so the male starts out higher, but at some age the female does overtake the male in normal systolic blood pressure as compared to age. Looks like that age is 50 where they kind of meet, and then the female blood pressure typically gets higher. All right, we need to solve this though. So essentially what we're looking for, right, is solving this where this equation equals 125. Because it says we've got this formula here that models the male's normal systolic blood pressure, and we want to find the age to the nearest year of a male whose systolic blood pressure is 125. Okay, so that's why we set 125 equal to this 0.006 a squared minus 0.02a plus 120. Rewriting the equation as a equals 0.006 a squared minus 0.02a minus 5 equals 0. The reason we did that is we have to have a 0 on one side. So essentially what we did here is subtract 125 on this side and subtracted 125 on that side. Oops. So that's 125 there. And that's how we got the negative 5 here. Okay, now that it's set equal to 0, I can use the values of a equals 0.006, b equals negative 0.02, and c equals negative 5 to plug it in the quadratic equation and solve it. Okay, so in the quadratic equation, I have a equals negative b, which in this case is negative 0.02, plus or minus the square root of b squared, so negative 0.02 squared, minus 4 times a, which is 0.006, times c, which is negative 5, all over 2 times a, which is 0.006. So, plugged it in the quadratic equation. That's how we got that part right there. Now, at this point, I would suggest using your calculator to simplify. Okay, so the simplification of what is under the square root is 0.1206. The simplification of the bottom is 0.012, and obviously the minus and negative here cancels out and makes it a positive. That's why we have a positive 0.02 to start the equation. Now, if we take the square root of 0.1204, we get approximately 0.347, right? We need to look at the negative and the positive of that, so subtracting and adding that particular section. And what we see is that if we subtract 0.347 from 0.02 and divide by 0.012, we get approximately negative 27. And if we add it, we get approximately 31. So those are our two solutions. But because this is a word problem, we have to think practically. Now, what are we talking about here? Okay, in this, we're talking about a male's normal systolic blood pressure at age A. And we're trying to find the age to the nearest year of this man. Can a man be negative 27 years old? No, a man cannot be negative 27 years old. That is why we reject this answer, because it does not make sense in terms of our problem. So the only answer that makes sense in terms of our problem is 31. Therefore, 31 is the approximate age for a male with a normal systolic blood pressure of 125 millimeters of mercury. Now, this concludes chapter 6.5. If you have any questions, don't hesitate to reach out by email. Please go on to try your homework. And this concludes the entire chapter of chapter 6. So, reach out to me if you need some help. Try your homework. Some of them might be kind of difficult. Factoring and the quadratic equation and doing that with applications can really throw students for a loop. So if you need help, don't hesitate to reach out. I want to help you. I want to help you get this right. Don't forget, like I said, if you're going to go X method for factoring, I highly suggest that instead of just watching the 3 or 4 examples that I did today with the X method, that you go on and further YouTube some extra practice for that on how to do the X method, because if you don't practice it, you won't get it. It's not something that just sticks automatically. Neither is the quadratic formula. It's something you need to practice. Practice it hard on your homework. Make sure you get it, and you should be okay. It's a very important factor moving into the rest of the mathematics you may take. If you have any questions, reach out once again, and I will see y'all next time for the next lecture. We will start chapter 7 next time.